Alright, so let's continue with the solution. We know that the maximum power gets delivered when the internal resistance of the batteries will be equal to the external load. Now that is possible when you have, you calculate the internal resistance, and the approach to do that is assume these 12 cells are organized as n cells in each rows and m such rows are considered. So which means the resistance of each row is nr, and since there are m rows, they are in parallel, the equivalent resistance is 1 by r equivalent is equal to 1 by nr plus 1 by nr till m times. So the equivalent resistance of the internal resistances comes out to be nr by m. You can see on the right hand side top. For the power to be maximum, or the current supplied to the external resistance to be maximum, this equivalent resistance of batteries should be equal to the external load, which I have put. So the ratio of n by m is equal to 3, and we know the total number of batteries is 12, organized as n into m is equal to 12. So if we solve these two equations, n by m is equal to 3 and n multiplied by m is equal to 12, we will get m is equal to 2 and n is equal to 6, which means there will be 2 rows, each row will have 6 batteries. This arrangement will give you maximum current or maximum power to the external load. Thank you.